the regional manager for Western North America at Rapidform. And today we want to talk about Rapidform's XOR software and our LiveTransfer to Autodesk Inventor interface. So Rapidform, as you may have heard, very recently became a part of the 3D Systems family. And 3D Systems is a leading provider of 3D printing technology, whether it be personal or professional or production printers. They have many options for customers in order to create high quality, high resolution 3D prints from their CAD. So we're very excited about our new coworkers and our new family, because it means we'll be able to develop stronger products faster and help address various market needs over the next couple years. So a little bit more about 3ds Rapidform is that Rapidform's been developed and been under development since 1998. We've gone through several generations of the product, and now we have 3 separate products, one of which we'll talk about today, which is XOR. Globally, we have over 10,000 licenses out there in the field with customers and applications that vary quite a bit, and we'll talk about those in just a minute. Rapidform has R&D centers and 3D Systems innovation centers all over the world, and we have 40 dedicated Rapidform R&D staff who are responsible for development of the software base, as well as researching new technology to make our software better and making sure our device interfaces are up to speed with the device manufacturers. And we really are an innovator of the modern scan-to-CAD workflow. And what I mean by that is CAD is typically parametric in nature, with a feature tree, parents, which are features like solids and extrusions, and children, which are features like sketches. So Rapidform innovated the scan to parametric CAD workflow for redesign. And you'll find as we demo the software a little bit and the transfer over to Autodesk Inventor, you'll see that all of our tools are very CAD-like, and they just make sense for a CAD designer. We have over 30 patents on portions of our software product, and we maintain a good, strong patent portfolio, and we're on the leading edge of scan data processing around the world. In-house, we have a great support network. We have offices, again, all over the world, and you've probably, if you're a customer, spoken with some of our just really sharp AEs that are there to help you out, and these guys know the software like the back of their hand, and we're here to help you. We also have a very strong reseller network, who is our first line of support. So we have our resellers all over the U.S. and the world that are there to help not only sell the product but support you as a customer, and we'll continue to do that. So now we're listed on the stock market. We're a publicly traded company, and you can find us under DDD. Had a nice bump in our stock price after our earnings this quarter. So check that out. So Rapidform has customers that vary in industry and in location, and our customers are visual effects companies, consumer product companies, aftermarket aerospace, aftermarket automotive, mining, United States government, and just general aerospace and automotive. So here's a small list of some of our larger customers where you'll find Rapidform software. Now, Rapidform is the fastest path to CAD. We say this all the time. The first step to get scan data is we need to use a 3D scanner or a 3D measurement device to acquire all the points in order to create our parametric solid model. The next step is going to be, of course, bringing your measured data into Rapidform, which is based on the Parasolid kernel. So we really are a CAD-based program that specializes in taking scan data and turning it into a parametric solid. So we do some very unique things in XOR that differentiate us from just a basic CAD software. We allow you to use specialized tools to cut corners and skip steps and make your reverse engineering process very quick and very accurate. So after we finish designing our model inside XOR and we have assured that we're as accurate as we need to be using our accuracy checking tools, we want to go ahead and transfer our feature tree over to one of our partners. Now we have a couple ways to export data. One is what we'll be talking about is LiveTransfer today, as well as just native uneditable file types actually. So what I'd like to do is talk a little bit more about Rapidform and give some demonstrations, as well as demonstrate the LiveTransfer capability to Autodesk Inventor today. Just real quickly, we'll talk about the workflow. Normally people will use hand tools and sketches and maybe cardboard-aided design to recreate a part inside their CAD software. And just taking, for example, this impeller, that could take up to 12 hours in CAD using just standard measurement tools. Now you could go one step further and purchase a 3D scanning device and attempt to bring that scan data into your CAD program and turn that into a parametric solid. But what you'll find is that most CAD programs have either no capability to import scan data, or if they do, what you can do with it is very limited. So you'll find yourself working very hard to take 3D scan data and turn it into CAD inside your dedicated CAD program. But with Rapidform, we are a hybrid of the scan data processing tools and CAD tools that you're already familiar using. And what we do is we help you take that scan and turn it into CAD very fast. The U.S. Air Force published a study that said that Rapidform is the only viable choice for parametric solid modeling, and that's a fantastic endorsement that we'd love to have. And this is a private study. Some things that you guys, you listeners may have possibly seen is the Jay Leno video that's up on our website, as well as the Big Dog Garage website. Jay Leno is a well-known customer of ours that owns a 3D scanner and actually looked around for a while to try to find the right 3D scan data processing software. And after trying some competitive software, they became a customer of ours, and we're very happy to have them. So here's an example of a part that's a corroded casting from a 1935 Fraser Nash. So with typical surfacing tools, it's going to be pretty much impossible this corroded part and turn it into a nice, crisp, solid model with design intent. Rapidform allows us to take this 3D scan data and turn it into a parametric solid using tools that you're already familiar with. So this is the process. The first step is to scan or import some scan data and take care of it in the way we need to. We need to maybe fill holes or smooth some areas, or maybe even just do an automatic fixing tools that we have. After we have the scan data kind of cleaned up in the way we want to work with it, we use our automatic feature recognition tools. So these automatic feature recognition tools allow us to break up the mesh into usable chunks and basically primitive shapes. Those different colors just indicate primitive objects. So I can actually click on that yellow part on the top of the model and use that as a plane. So the end result is we're trying to get an intelligent model from 3D scan data. And automatic feature recognition adds a little intelligence or a layer of intelligence onto our mesh, and then from that intelligence and those primitives we were able to create an actual solid. So the next step after region grouping is to create some sketches. So we'll take cross sections through our part and we'll get a reference outline that's pink, and then we just need to convert that outline to a dimensioned or constrained sketch. So obviously once you have sketches, we can go ahead and extrude features, add some details, and then go ahead and LiveTransfer to our CAD software. So let's take a look at Rapidform XOR as well as the LiveTransfer interface to Autodesk Inventor. I'm going to go ahead and bring up Rapidform. So here's a part that I'll go ahead and hide solid. Here's a scan data set that was actually intentionally scanned poorly. This is a good example of the same type of modeling tools that we use on the Fraser-Nash. We don't need to have perfect scan data. We have clearly lots of holes here, lots of noise because it was scanned on a non-rigid surface, and the setup was poor, but we did this on purpose to show that we can take a solid like this, or I'm sorry, a mesh like this, and turn it into a beautiful parametric solid. So let's talk about how XOR works. So we can easily roll forward and roll back through our history tree in order to discover how this model was created. So if I roll to the top, you can see this is my mesh. And the next step is going to be to region group it, as I said before. And what region grouping has done is taken these mesh segments and turned them into usable pieces and usable chunks. So now I can treat this flat surface on the mesh as a plane just by clicking on it. I can treat this surface as a cylinder. And from these region groups, we have the ability to offset planar geometry and get get a mesh sketch. So in order to get the profile of this part, what I need to do is pick a base plane, and then I can drag a cross section that's parallel to my base plane through my part. And what this cross section does is intersect a plane with the part at the height and then project the resulting profile onto the base plane that I chose. So once we select our cross section, we can go into sketching mode. So Rapidform has a full sketching and constraint capability. So what we can do is choose a line tool and just go ahead and click and fit on a line. So we're now rapidly walking through the reverse engineering process. And using tools that you're already familiar with using in CAD, such as line sketching, corner trimming, and dimensioning, in order to create the sketch that we're going to end up using for a solid. So if I want to maybe change a dimension and make this rounded off, it's very easy to just access my dimension and adjust it. Let's go ahead and extrude this to make a solid. So once I've created a solid, I can now use my accuracy analysis tools to check the deviation from the mesh, which is our reference that the solid has. Let me loosen up my tolerance here. So you can see on the edges, our sketch is very tight and true to the part. And on the top, we've got some blue, which means we're under material and need to remove some more stuff. So we can also do accuracy analysis on the 2D level as well as the 3D level. So if I need to, I can double check to see how accurate my sketch is by gauging the 2D accuracy. So we can easily roll forward and take a look at the design process. What we've got here is a model that's almost done. I'm going to add one more feature just to show you Mesh Sketch, and then we'll go ahead and live transfer this over to Inventor. So again, for Mesh Sketch, what I need to do is choose a base plane, which I've already got a plane right here on this side of the part. And from this base plane, I'm going to cut a cross section through the part. So I just simply drag it through my part. Now, let's say I don't have complete scan data in that region. You can notice I have a big arrow and I have a small arrow. The small arrow allows us to drag a volume through our part, which gives us a more solid profile when you have incomplete scan data. It's a great tool to use. So having selected the offset distance that I need, I'm going to go ahead and accept the mesh sketch, get the view the way I need it, and I'm just going to simply model the two lines that define that little pocket. And I believe this actually is supposed to be a through hole, so I'm going to also draw on the top a bounding box. So I'll have a bound up here, have a bound down here, and I can easily extend, 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 and trim these guys off. Now, after we have a sketch, we simply use the same type of tools you're already used to using in CAD, such as extrude, surface extrude or solid extrude, revolution, sweep, loft. These tools work very similarly as they do in your CAD software. Now, what we have that's different is we have region groups. We can do unidirectional or bidirectional extrusions up to a surface, body, and a vertex, as well as a region. So what I'm going to do is actually just drag my extrusion up to the point where it snaps. And you can see that it's given me a blind length of 1.62 for the extrusion. So if I want to round this off or round this down, I'll go ahead and make it 1.6. Maybe that's what the caliper says. So we'll go ahead and make sure this is an extrude cut as opposed to an extrude merge and accept it. Now we can see the feature has been made. So now when we're done with this and we've gauged the accuracy and we know how accurate the part is and we're willing to commit these changes to SolidWorks and we're willing to commit this part to SolidWorks, I'm sorry, AutoCAD Inventor, let's go ahead and use File, LiveTransfer to Inventor. So we can either start from the top, or we can just LiveTransfer selected entities to Inventor. We can also export this as an uneditable solid, Parasolid, Step, IGES, ACES. So I'll go ahead and accept the LiveTransfer and bring up Inventor. So the LiveTransfer tool is a parametric exchange between Rapidform and AutoCAD Inventor. So sometimes you have parts of the solid that are not supported inside Inventor. So what we need to do is modify our part to make sure that the part comes through okay. So I'll go ahead and open up the sketch, which it is indicated was a warning. Make a modification to close this profile and accept it. Now if I revolve this sketch around my axis, I go ahead and cut that away. Using this as my tool, and that is my target. So now in order to continue the transfer, we'll just go back and select where we left off and move forward. So moving right along, what we can do is start this guy over. and our part will be complete. Let's take a look at one more part inside XOR and its live transfer to Inventor. So here's an example of another part. It's just a demonstration part that we use. And what I want to do is check my accuracy on the part after I finish modeling it. And I can see that this is accurate within my tolerance. And then we'll live transfer this to Inventor. Now you'll see that a sheet body just came in, and let's talk about what that is and how that was transferred over. So if we move to the top of our file, you'll see that when we created this extrusion, we extruded it directly up to a region group. Now I could have extruded this past the region, fit a surface to it, and then cut with that surface. But with XOR, we can use the region groups as if they were already geometry. And as we saw, this imports directly into Inventor as a surface, like a sheet, an imported body. Well, what if we want to make this more parametric? We can adjust how it's transferred by changing the way that it's extruded. So if we roll back, we can select the top of the body and then choose one of our wizard tools. The wizard tools are going to help us model things faster by using region groups as input. So if I select the loft wizard and click the top of my part, I can square up my proposed cross-section path, go to my next step, and now I have a parametric lofted surface. This is something that's editable and controllable inside Inventor. So now we can edit the way this is extruded, and extrude it right up to a surface as opposed to the region. Now we have something that is parametric. And we'll watch how this transfers. So as you can see, the first element in the tree is a 3D sketch that contains the cross-sections that were generated in XOR. The next element is going to be the lofted surface that connects those 3D sketch elements together. What I'd also like to show you is a little bit about our quick modeling workflow, which creates parametric geometry with just a few clicks of a button. And this also live transfers directly over to Inventor. So if we take a look at this feature here, this cylindrical feature with a sphere at the top, we know that this has a center line and is probably a revolution. So if I delete that feature, I'll go back and remodel it using our quick modeling workflow. So in order to make a cut with this feature, I simply just select 3 regions or a few regions inside the feature, right-click on it, press Cut. Now, Rapidform has gone and found that this is a revolution. And it's automatically found the revolution wizard, established the center line. When I go to my next step, it's also created a plane, a sketch, as well as the solid. We check our accuracy. Now it's important to also pay attention to our compatibility tool down here. It's explaining to me that I might want to close up this revolution in order for this to transfer all the way to Inventor. So let's go ahead and turn off some sketches here. And I'm going to close the profile. And the revolution automatically updates with the new sketch data. So let's go ahead and live transfer this. What you'll see is that using one of our wizards allowed us to create parametric geometry almost automatically. And this live transferred just fine. Let's take a look at one more file. This is an example of a very complex part. So we're going to obviously have a long live transfer process. What I want to do is maybe take a look at some of the things that might be an issue inside live transfer and try to resolve those before I do it. So let's see how this live transfers. So we need to fix one thing, which is how this is cut. We just simply step back over to Rapidform and change the way this is cut. So instead of using a single line to cut this with a sketch as a tool, maybe we need to cut this as a solid. We'll go ahead and extrude, cut, accept it. And then we select where we left off and continue to live transfer. Now, if we have to resolve something, we could easily do it inside inside Inventor by saying extrude, choose our profile, and then choose our distances and what we want to do with it. So what I'd like to do is wrap up by talking a little bit about some of the applications for Rapidform that you might see every day. So we have customers that do aftermarket automotive design who will take the entire engine of a car apart in order to rebuild certain components or start with a component design in order to modify it and for performance tuning. We also have many aerospace and transportation customers that need to understand existing geometry in order to design around something. Maybe this customer was designing a wing locker for this airplane. Consumer products. If you have a cell phone and you have a case on it, chances are Rapidform helped put that there. In order to design a protective case for a cell phone or tablet, you have to understand the existing geometry in order to design around it. Also in tooling, we have numerous tools to help you rapidly model and reverse engineer tools, as well as correct your tools for existing conditions. And so many more things. Thanks a bunch for your time today. Again, my name is Scott Green. I'm the Western Regional Manager for Rapidform, and my contact information is there. You can reach me at scott.green@rapidform.com. Thanks so much for your time, guys.
Thank you, Scott. So we have a few questions that have been posed by some of the members of the audience. The first one is, can I get a copy of this video after the webinar? And the answer to that is yes. That will be available on the Rapidform website a little bit later on today. If you go to rapidform.com and look under the About Us section, you'll see something called Recorded Webinars. And if you go there, you can watch this webinar as well as a variety of other webinars that cover different topics about Rapidform, available again under the About Us section. Here's a technical question for you, Scott. Why are there issues with LiveTransfer to Inventor?
So every LiveTransfer is a little unique. If we go to the demo block here, every CAD software works just slightly differently. And what we like to do is, as we model, choose our compatibility checker to make sure that whatever we're modeling models clean and transfers clean over to Inventor. So you can actually mitigate any transfer issues by paying attention to the CAD compatibility as you model. Does that answer your question?
Yeah, I think that probably did answer that question. So the next question is, you talked a little bit about something called quick modeling, and you said that it can figure out certain shapes itself. Can you talk about sort of the limitations of quick modeling, where it works and where it doesn't?
Yeah, sure, no problem. If we take this model, for instance, of course, the first thing we want to do after bringing the scan data in is region group it. Quick modeling is going to need from us region groups in order to create or understand the solid. So the quick modeling workflow relies upon our wizards, which are up here. So in order to model this as an extrusion, or sorry, an extrude cut, if I roll back here, roll forward. So let's say I'd like to model an extrude cut right here. I'm going to need to have a bottom and a side in order to make that. So if I click the side and the bottom, I can either right click and say cut some material out, or go to my extrusion wizard. And if you'll see right here, it automatically found out what side was relevant and where the bottom is. So quick modeling works for extrusions, revolutions, sweeps, and lofts. So in order to be able to successfully complete a quick modeling command, you'll have to have the basic information needed to define an extrusion, which would be where does it start, where does it finish, and what are the bounds. So some sides and a top and a bottom. And similarly for a revolution or a sweep, we'll have to have a profile and a path and an axis. Does that help?
I think it does. Next question is, we currently have a copy of RapidWorks. How does the full edition of Rapidform differ from RapidWorks?
That's a good question. There is no difference other than what kind of data you can import or use inside of RapidWorks. So RapidWorks is a specialized version of Rapidform that works only with data from the NextEngine 3D scanner. Its capabilities and functions are completely identical to Rapidform's XOR3. The only difference is XOR3 can allow you to scan directly inside our software or import STL and OBJ files or one of our many different hardware partners' native file types. So the amount of tools, the amount of data that you can use or the types of data you can use are very numerous as opposed to the single source that RapidWorks can use.
And there's a follow-up question to that, which is how would one go about getting training for Rapidform?
Sure. Rapidform has monthly training sessions at our Lakewood, Colorado headquarters for the software company. And we also do several regional training sessions all over the U.S. So if you'd like to get some more information on where the next training session is, you can actually find that out on our website. Or you can email me directly, and I'll link you to the website and help you get signed up.
Okay, another question is, can we use this software to compare CAD and scan? And I think this might be a question more about Rapidform XOV.
Sure. Yeah, we actually have 3 separate products. XOR is the one we talked about today. XOV is our verification software, which allows us to import CAD files or a reference data set, and then import a measured data set, align them to each other, and then perform geometric dimensioning and tolerancing. So we have a separate software product for that, but we are capable of doing accuracy analysis as we model inside Rapidform. So you don't need to buy XOV to understand general form deviation, like is this model true to the scan data. It's more for an inspection type application where a product was produced from a CAD file.
Okay. And another question is, to which other CAD systems can Rapidform transfer?
Sure. Rapidform can live transfer to AutoCAD, AutoCAD Inventor, Creo Pro-E, Siemens NX, and SolidWorks.
And what I see CATIA listed there?
Yes. CATIA, we have a file export to CATIA, as well as a file export to the standard uneditable file types.
And I think we have one last question here. What is the difference between reverse engineering and shape capture?
So shape capture is going to be, if I understand your question correctly, reverse engineering is going to be largely dimension driven and solid modeling, and maybe shape capture could possibly be NURB surfacing or shrink wrapping around a scan data set. If you just want to understand the area you're modeling into with the general shape, you can use looser modeling methods as opposed to refined dimensioned sketching. So we could still shape capture model or model as built geometry inside Rapidform. It would just be a lot easier.
All right, I think that does it for the questions, and we're 40 minutes in now, so it's a good time to end the webinar.
Okay, great. Thanks everybody for coming, and I look forward to talking to you in the future.